Now, before we explore exactly why this compiler error is happening, let's talk a little bit about our ArrayMap class. So the ArrayMap is one of many possible ways to implement a map, and we'll see after Project 2 other better ways. But for now, we're keeping it very simple with an array. So the basic idea here is to use an array as the core data structure, and to, anytime we need to add a new key value pair, put them both at the end of an array in the same position. So each key always goes with the value in the corresponding position in the other array. So whenever we do put kv, for example, we just find k, or the key, and if that key is not in the list, we'll put them both at the end of the array. And if they're not negative, then what we'll do is, if the index is not negative, that means the key is there, and we just set the value, okay, as we saw. So we had the put method, which we wrote get contains key and keys. Not going to go over those again. But the one thing I do want to say about terminology, just ever so briefly, is that when we actually create our class, when we define it, we have up here what are known as sometimes generic type variables. So at the time that you and I were writing this code, we don't know if somebody's going to make a map from integers to strings, strings to strings, dogs to horses, whatever, and we just use k and v. And the special notation lets us treat the type itself as a kind of variable. And then when we instantiate one of these things, we provide what are sometimes called actual type arguments. So that essentially now this whole thing gets treated like that k was integer and v was string all along. Okay. Now, again, I guess I should mention it briefly, in Java 8 or later, you can actually omit this bit over here, and it will infer it automatically from the declaration of a variable, and you can only use that, of course, when you're declaring a variable. Okay. So this brings us to that error that we were interested in. So in this case, this is the command line version of the same error. I mean, it's this thing here. And it's that there's an ambiguous method call. So what Java is saying is, I don't know if you meant assert equals long long or assert equals object object. Now that might seem a little strange because if you look, it's actually int integer. So it's like, how did we get to long or object? But fundamentally, the issue is if we look at the JUnit source code, which I can't seem to get another window. Okay, let's see. There we go. So we do grep code assert equals JUnit, which I've done earlier. Then you can see this is the code that actually is JUnit itself. So you can browse it if you want. And we can see there's a bunch of different assert equals methods. For example, assert equals object object. We have assert equals long long, assert equals double double, and so forth. And so what the Java compiler is complaining about here is that it doesn't know. It does not know which one we mean. So how is that possible? Well, I'd like you to think about this a little on your own. Think, what automatic conversions do we need to get from int integer? That's what we had here, right? Assert equals expected, that's an int, and am.get2, that returns a capital I integer. So if we did some set of automatic conversions, what would we need to get to, or do to get from int integer to long long? And I'll let you think about this for a few seconds. Okay, so hopefully you paused and thought about it. So there's a bunch of possibilities here. And the first question is, how do we get from int to long? Well, in this case, all we need to do is just widen. So to get from int to long, we just need to widen expected, in this case, to long. Down here, to get from am.get2, from integer to long, in this case, we have an integer that's wrapped up. So we need to first unwrap it, and then we need to widen it to make it into a long. So in total, we can think of it as there's 3 different steps that happen. Okay? That's one way to imagine it. So we know that given Java's automatic conversion system, you can get from int integer to long long. Now the actual rules about how many conversions you can do at once, it's a little complicated actually, and it's not part of the class. So you can try experimenting on your own later if you'd like, but that's just to let you know. There exists in this case a way to get from int integer to long long. Now the ambiguous call, if we look at what the IntelliJ compiler was telling us, it said it's also possible apparently to get to object object. So a question for you here is to consider what automatic conversions do we need to get to get from int integer to object object. So I'll let you think about that. You can pause me and I'll spoil it. Okay, so what happens in this case is to get from int to object, we need to box up int to integer. And then we have integer integer. And an integer is an object. So arguably we're done then. We just have integer, integer, and an integer is an object, so we're totally done. So it's only one conversion. Now, it kind of depends on whether or not you count the conversion from integer to object. If we actually look at the Java specification, they consider moving from integer to object a conversion, but I personally find that term a little confusing because nothing happens at runtime. So when you go from int to integer, you actually get a runtime change. You originally just had 32 bits, and now you have 96 bits. It's like a totally different arrangement of bits. Going from integer to object, though, there's nothing that happens at runtime, so I don't really consider it a conversion, but maybe the designers of Java disagree. So what I would say is that even though this is easier than the three-step process needed to get to assert equals long, long, it's still ambiguous, and thus Java won't even let this code compile because it doesn't know what you mean, because there's two different conversions that are allowable. So why do I bring this up, right? It seems like I'm alluding to things that are complicated. I'm arguing with the Java language designers about what constitutes a conversion, and probably you're getting a little nervous. Probably you're imagining some hellish midterm problem or something, but I'm not going to subject you to that. The type system in Java, I want it to work for us, and I don't want to suffer. So I will avoid giving you totally obscure typing problems in the future, because that's something you can always deal with a compiler. However, I think it's important that we see this because it will likely come up with your project too, because you're going to try and assert equal some things and run into weird issues. So how do we actually get this code to compile? So what I'd like you to do now is come up with a cast so that there's no ambiguity. And the way it'll work is you want it so that there's an automatic exact match and there's no need for any runtime conversions, no need for any weird changes to happen. It's a tricky question, but really try to think about it. So try and figure out something where there's a zero-step conversion. So one possibility is I want it to go straight to object, object. And so I could do that by forcing this on the left to be an object. So by casting this to integer, I can head off our type system, and I now have a perfectly lovely thing, and it will call the object object version. And then when we run this, hopefully we'll find that it correctly runs the test. Oh, actually, I need to do ArrayMap. Okay, we'll run the tests, and our one test passes. Okay, good. Sorry, our one test passes. Great. And so there are other answers you could try and do. You can do the other way. You can try and cast it so you actually call the long, long version, an exercise for the reader.